Hello and welcome to this episode in our Mastering Deep Learning series. And in this video, we are going to continue with our studies on Numpy, and we are going to focus on broadcasting, which is a very important feature or technique that you really have to understand to be able to successfully apply Numpy to most of your linear algebra calculations, and for that matter, building neural networks in the future. Now, the whole idea of broadcasting is simple. It basically helps you to perform linear algebra calculations on matrices and vectors of different shapes and sizes. And I'm saying this in context because there is a condition under which broadcasting is possible, and I'm going to explain that to you in this video. Because these things are best explained with examples, I'm going to do that. So I'm going to create array 1, and I'm going to call it np dot array. Let me put in 1 2 3. Okay, now let's see the shape of a1. We are getting a tuple with just one element, 3. So what this thing is basically telling us is that this is a vector with 3 elements. Okay, how do you know if this is a column vector or this is a row vector? I mean, if you are reading the dimensions of a matrix, you read the rows first and then you read the columns second. Now you print the shape of this and then you get 3. I'm going to go ahead to make a change for you to see like some difference here. I'm going to say a2 is equal to np.array, and then I'll say 1. Take note and see that each entry is in its own square bracket. Okay, and then let's print a2.shape. So you can see that putting the individual items in square brackets is actually what results in getting a new row. So what a2 is a column vector which has 3 rows and then 1 column. And then this is just a vector with 3 elements. So what I'm trying to draw your attention to is that if you want to create a column vector or a row vector, you need to be explicit about how you structure the items in the array. I'm going to make a video on array reshaping and stuff like that so you understand, but I needed to mention this so that you don't have issues with it in the future. Okay, now let's come to the topic of broadcasting. Let's say I have an array. I'm going to call it A is equal to np.array, and then I'm going to put in 1 2 3. Okay, now I'm going to add a scalar to this array or vector. So I'm going to say A plus 1, and see that 1 has been added to every single element in A. The question is, how is it even possible to add a scalar to a vector? What actually happened behind the scenes is that Numpy realized that, okay, so A is a vector or an array with 3 items, and you're trying to add it to a scalar, which is an item that stands on its own. So what Numpy actually did was, it is going to broadcast this 1, okay? The thing to understand here is it is going to look at which side has the biggest number of items on the axis that it wants to broadcast on. So it realized that this is 1 is just a scalar, but then A is an array with 3 items. So what's going to happen is it will broadcast 1 3 times. So this line of code on line 10 is actually the same as np.array 1 2 3 plus np.array, and then it's going to broadcast 1 3 times. Okay, if I do this, you realize that we get the same output as on line 10 or on line 11 when we just added a scalar to a numpy vector. Okay, so that is the idea of broadcasting. Let's take it further to doing it on multi-dimensional arrays. Okay, so I'm going to create another array here. I'm going to call it np.array, and see that I'm going to put two rows. Sorry, I want this thing to go away. Yeah, so I'm going to put two rows into the array A. So I'm going to put 4, 5, 6, and then I'll come to the next line, and then I'll put 7, 8, and 9. Okay, so let's print out A, and you can see that basically A is a two-dimensional array with 2 rows and then 3 columns. Okay, now what happens when we add a vector whose size doesn't actually match array A in terms of the dimensions of all the axes? Okay, so I'm going to create B, and I'm going to say it's equal to np.array, and then I'm going to do 1, 2, and then 3. Okay, so now I'm going to say C is equal to A plus B. Let's see what happens, and let's print C. So basically you can see that it had to repeat the array B twice. How did Numpy figure that out? Okay, so it realized that for array A, let's see the shape of array A. So A dot shape is 2 by 3. Let me actually do this everything on the same line. So A dot shape and then B dot shape. Okay, so it realized that, well, A has a shape of 2 by 3, and then the vector B is a vector of 3 items. Is it a row vector? Is it a column vector? It knows that it has 3 items, and this has 2 rows and also 3 items, which is on the column axis. Okay, so what Numpy is going to do is it is going to broadcast, or is going to repeat 1, 2, 3 twice, because at least it matches on this axis. There is 3 here, there is 3 here, but then 2 here, and then there is nothing. So what's going to happen is it's going to repeat B twice to be able to perform the calculation. So actually this is the same as doing this np.array, and then we have 4, 5, 6, and then we also have 7, 8, and then 9, plus np.array, and then we have 1, 2, 3, 1, 2, 3. So broadcasting is actually taking care of repeating the shorter array along the axis where broadcasting is needed, so that the calculation is valid to be performed. Okay, now I'm going to do one more example, and then we'll call this video finished. Okay, so I hope you've understood it up to this point. I'm going to create a new array, and then I'm going to perform some calculation with it. So I'm going to call this, what do I call this? Let me call this data. And I'm going to say data is equal to np.array. And then I'm going to put in, I'm going to put in 4, 5, 6. And then over here, I'm going to put in 7, 8, and then 9. So we have data array over here. Okay, now let's create another. I don't know what to call this, but what do I want to call this? What do I want to call this? I mean, I'll just call this data1. This is a bad variable name, but I'll do that anyway. So I'm going to put in 1 and then 2. Okay, so before we do the calculation, let's see the shapes of each of them. So I'm going to say print data.shape and then data1.shape. So you can see that This is an array with 2 rows, that is data is 2 rows and then 3 columns. And data 1 is an array with 2 elements. Now let's try to do some summation and see. Data 1 plus, no, I'm going to do data plus data 1. And poof, see, it says value error. Operands could not be broadcast together with shapes 2, 3, 2. I mean, this can be confusing, and this will happen a lot more times if you don't spend time to understand broadcasting. This will happen many times when you begin to build neural networks with Numpy. So it is important that you take all the time you need to take to understand how broadcasting actually works. And so, why do you think this is happening? I want you to keep in mind though that the number of elements along the explicit axis and the implicit grid have to match so that NumPy can perform a sensical operation. Okay, you are giving it a 2 by 3 array and is adding that to a vector of 2 items. It doesn't know whether this vector is a column vector or a row vector. So it helps to be explicit when you want broadcasting to work best for you. Now, it knows that this is a vector of 2 elements. If it knew it was a column vector, which means it is a vector with 2 rows and 1 column, then it is going to broadcast it along the horizontal to be able to do the calculation for you. What do I mean by all this rant? Let me recreate data 1. So I say data 1 is equal to np.array, and then see what I'm going to do. 1 and then 2. Okay. Now if I print the shape, data1.shape, you can see that now it is clear that this is a column vector with 2 rows. And so it can be broadcast. I mean, NumPy can handle the broadcasting between a 2 by 1 and a 2 by 3 because now it knows that they both have 2 rows, and then data has 3 columns, but data 1 has 1 column. So it's going to repeat data 1 3 times on the horizontal. Basically, it's going to replicate it to become a 2 by 3, and then it will do the addition. So now let's do data plus data 1. And now you see that it works. So what it basically did was it's going to repeat data 1 along the horizontal, and I mean it's going to make sure that it also has 3 columns just as this one has. So basically the idea of broadcasting, like I said, is to help you to be able to perform numerical computations on arrays and vectors of different shapes and sizes. But then it can be troubling if you don't understand what's going on. So my best advice for you is always make sure your arrays have explicit shapes on both axes. Don't create an array that is just an array that has 2 items. Is it a column vector? Is it a row vector? That is hard to tell. And this becomes an issue when you try to do broadcasting. So I'll be teaching you how to reshape in the next video. And I want you to really understand broadcasting and also understand how to do reshaping because they work together. Whenever you're having these issues with broadcasting, you need to know that reshaping your array is going to help you to get back in a form where NumPy can properly handle your broadcasting for you. So thank you very much for watching, and I'll see you in the next video.